So we are going to see some basic definitions. First, secant. Let P be any point on a given circle and Q be a point on the circle other than P. Join PQ. Then the line PQ is called secant of the circle. Secant of the circle is a straight line passes through the interior of the circle and intersect the circle at exactly two distinct points on the circle. It is a line passes through the circle, so from this side to that side, right? That is called a secant. So if it is passes through the center, then it is called diameter, right? So we'll see P is any point on the circle, Q is other point other than P. Join PQ, that is called secant, right? So tangent. Tangent of a circle is a straight line that touches the circle at exactly one point. If a line touches the circle at exactly one point, that is point of intersection is only one between the line and circle, then the line is called tangent to the circle. The line never passes through the interior of the circle, right? The tangent line always perpendicular to the radius of the circle. If you join the point of intersection of that line and circle and the center, you will get the radial line, right? That radial line and tangent is always perpendicular to each other, right? So this is tangent. C is the center. If you join, then PC is perpendicular to the tangent, PT. If the point Q approaches P along the circle, then PQ is the tangent of the circle. Now see the blue line, you are having P and Q, 2 points. If your Q is rotating, right, approaching on the circle, right, on the boundary of the circle, right, if it is moving from that point through the clockwise, right, so if it is going like this, the line will be changing, right, the direction, so automatically it will change the direction, and if it is coincide with that, then the line will be like the tangent PT, green line, right? So that is why if C is the center of the circle, then CP is the radius of the circle, then the tangent PT is perpendicular to CP. Length of a tangent. Consider a circle with center C and P is any point exterior to the circle, that is the external point. So C is the center, P is any point outside the circle. Draw a tangent line PT from the point P to the circle. So draw a line which is touching the circle at one point, right? That is which touches the circle at T. The point of intersection of the line and circle is T. Then PT is the length of the tangent from the point P to the circle. So the length PT is nothing but length of the tangent. Power of your point. Consider a circle with center C and radius R. Let P be any point on the plane, right? So consider the circle with center C and P is any point outside the circle, right? Join CP, right? Now CP square minus R square is called the power of the point P. So R is the radius, CP is the length, right, from center to the particular point, any point outside or inside or on the circle, right? Then the difference between CP square minus the radius of the circle square of the radius minus R square is called power of the particular point P which with respect to the given circle. A point P lies interior on or exterior to the given circle according to as the power point of P with respect to the given circle is negative, 0 or positive. So distance, we are calculating the difference between the distance and the radius, right? Square of the distance of the line CP and the radius, right? Suppose CP P is outside, then suppose the point of intersection of the line and circle is Q, then CP is always greater than CQ, CQ is radius, right? So CP square is always greater than radius square. So CP square minus R square positive. If it is on the line, CP square is nothing but radius. So CP square and R square both are equal. So CP square minus R square is 0, right? Suppose the P is inside the circle. If you extend that point, it will meet the circle at Q. Then CQ is the radius. CQ is more than the distance CP, right? If it is inside. Therefore, CP square minus R square is negative. That is the idea, right? First result, the power of your point P x1 y1 with respect to a circle x square plus y square plus 2gx plus 2fy plus c is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, right? So we'll see this is the power of the point with respect to the point x1 y. Just we are replacing x by x1 and y by y1. So we will get a number that is called the power of the point P with respect to the given circle. We know that center C and the radius R of the given circle is minus g minus f, and R is root of g square plus f square minus c respectively. We know that the power of a point P is given by CP square minus R square. Now CP square minus R square is equal to, we are using the distance formula. We know C minus g minus f. P is x1 y1. So distance between 2 points, we are using x2 minus x1 the whole square plus y2 minus y1 the whole square. That is the formula, root of, right? So instead of x2 we are taking x1, instead of x1 we are taking minus g, or otherwise instead of x2 we are taking minus g, and instead of y2 we are taking minus f, and x1 y1 as it is. So x1 minus g the whole square plus y1 minus f the whole square within the square root, that is CP. CP square means square root the square, right? Minus R square. R is, we know, root of g square plus f square minus c the whole square, right? So CP square minus R square is equal to, so the power root will cancel because squaring the root automatically will get cancelled. So x1 plus g the whole square plus y1 plus f the whole square minus g square plus f square minus c. So using a plus b whole square formula, x1 square plus g square plus 2gx1 plus y1 square plus f square plus 2f(y1) minus g square minus f square minus of minus plus c. So this implies the power of the point P x1 y1 with respect to the given circle is x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c, because g square minus g square get cancelled, f square minus f square get cancelled, remaining you are having this one, right? Next result, consider the circle x square plus y square plus 2gx plus 2fy plus c equal to 0, and P x1 y1 is any point on the plane. If a straight line passes through the point P, cuts the given circle at 2 points A and B, then the power of the point P with respect to a given circle is equal to PA into PB, right? We'll see the proof. Given circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. So this is the circle with center C. P x1 y1 any point outside the circle. So a line from P cuts the circle at 2 points A and B. We know that any point xy on the straight line PAB can be represented by x is equal to, we are using parametric equation, right? X is equal to x1 plus r cos theta and y is equal to y1 plus r sin theta. That is equation number 2, where r is the distance from, not radius. Note that this is the distance from the point P x1 y1 to the point on the line, right, xy. That is the distance. Suppose if it is A, then PA is the distance. Suppose the point is B, then PB is the distance, right? That is the distance r, right? And theta is the angle of inclination of the line PAB. So the line PAB, so assume that there is a horizontal line. So the angle between the horizontal line and PAB, that is nothing but inclination, right? X direction, right? Note that the point A and B, which are lying on both the line and the circle, are also represented by the point 2. because A and B are lying on the line, right, PAB. Any point on the PAB represented by the equation 2. Therefore, A also represented by equation 2, B also represented by the equation 2. So put x is equal to x1 r cos theta and y is equal to y1 plus r sin theta in 1, right, because that point is lying on circle also. That is why we are putting that point. So substituting x1 plus r cos theta the whole square plus y1 plus r sin theta the whole square plus 2g x1 plus r cos theta plus 2f y1 plus r sin theta plus c equal to 0. So using a plus b whole square formula, simplifying x1 square plus r square cos square theta plus 2r x1 cos theta plus y1 square plus r square sin square theta plus 2r y1 sin theta plus 2g x1 2g into r cos theta, right, 2rg cos theta 2f into y1 2f into r sin theta 2rf sin theta plus c equal to 0. So grouping r square term, right, first r square into cos square then sin square, right, cos square plus sin square. Then grouping 2r term, 2r into x1 cos theta plus y1 sin theta then g cos theta plus f sin theta. Then remaining terms x1 square plus y1 square plus 2g x1 plus 2f y1 plus c equal to 0. That is equation number 3 which is a quadratic in R, right? So quadratic in R means it has two roots, that is, let it be R1 and R2, right? So R1 R1 and R2 are two roots, but R is the distance, right, from any point on the line PAB, right, from any point, from the particular point P x1 y1. So that is the distance from the point P x1 y1 to any point on the line, right, xy. So A is any point means, so that is the distance PA, that is nothing but R, let it be R1, and B is any point on the line PAB, then the distance PB is nothing but a distance in the line, it is represented by R2, right. We know that product of roots of the quadratic equation ax square plus bx plus c equal to 0 is from theory of equation C by A, product of roots. Suppose if you are having two roots x1 and x2, product of roots x1 into x2 is equal to C by A, right, that we are using that idea here. So A is equal to 1, C is equal to x1 square plus y1 square plus 2g x1 plus 2f y1 plus c, right. So therefore product of the root r1 into r2 is equal to x1 square plus y1 square plus 2g x1 plus 2f y1 plus c by 1, right. Therefore PA into PB is equal to x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. This is nothing but power of the point P with respect to the given circle, right. So PA into PB is equal to power of the point. Next result, if x square plus y square plus 2gx plus 2fy plus c equal to 0 is a circle and P x1 y1 is any exterior point with respect to the given circle, then length of the tangent from the point P x1 y1 to the given circle is root of x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. So this is the circle, this is the point outside the circle. So drawing a tangent from that point, right, P x1 y1 touches the circle at A, let it be A. From the above result to second result, PA into PA, instead of PA.PB, it is cutting only at only one point, right. So if it is 2 point, PA into PB. Now we are taking 2 times, right, PA into PA is power of the point P x1 y1, that is equal to x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. So PA square is equal to x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. Therefore PA, that is nothing but length of the tangent, right. PA is equal to root of x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. Thanks.